So initially it was like one, like a difference between one, and then now it's like this is 61 degrees like greater than this one.
Okay.
So
All right. So this you're saying is 61 degrees greater than that one.
mhm.
Is there any, if let's see if you can find a relationship between how they're changing between both of them together. What's happening in one in relation to the other? So
Maybe
take you back
it's
to the
taking
beginning.
like from here and then putting it here.
Oh, check it. See if it's true. So if you want to even start back from the beginning, you can go. You just press the back button, and it'll take you back to 90.
Oh.
All right, now you're at 90.
So like if I move this a certain
Mm-hmm.
amount, it'll take from here,
Mm-hmm.
and it'll cause this one to like become smaller.
Okay.
Yeah.
So how much this one loses, this
Goes
one
to
gains.
the other side. Yeah.
Okay. All right. That makes sense. So together, what do you think they add up to be? Sum up to be?
They should equal 180, right? 108 and 71, which is pretty close to 180 because I rounded it up.
Mm-hmm.
Yeah.
So you're saying together they always, or what's happening?
Like they should equal 180 if it's gonna be like a straight line.
Okay.
Like added together, I guess.
Mm-hmm. And since I'm moving it, they should still equal 180 is what you're saying?
Yeah.
But what's happening?
They're still like kind of shifting.
Mm-hmm.
Like it together they should equal 180, but even if like one side is smaller than the other.
Okay.
So if you're gonna like increase this side by a certain amount, it
Mhm.
should be taken from this side. So
Okay.
yeah.
Okay. So now we've talked about how the angles are changing in relation to each other, right? Let's talk about in relation to this segment, and the angles. Is there any relationship between the angle measurements and the segments? How these segments are changing?
This one should equal this one and vice versa, right?
Okay. What do you mean? The angle?
Like yeah.
Okay,
the
so
angle.
this angle should equal that angle.
Yes.
And this angle should equal that angle.
Yes.
Okay, good. And before initially you said the square.
They'd all equal 90.
Okay, good. So now, so as you're shifting it, you're saying this is getting bigger.
Mm-hmm.
Okay. As this is getting bigger, what's happening to these two? And exactly how is it happening?
Well, the distance here is getting shorter while this one's getting greater
Mm-hmm.
because you're moving this one farther away.
Mm-hmm.
Yes.
Okay. So, and what exactly is happening to this angle as we're moving it?
It's increasing.
Okay, so what's the relationship between this angle and this segment?
The distance isn't as large as the other side.
Okay, so can you tell me, like in words, if you were to tell someone the relationship between what's happening to this angle and what's happening to this segment? And you can move it if you need to. Say, so as this part is the only one you can move.
Yeah.
So as this one is something, this is something. What is that?
As this one is decreasing or increasing, this one will decrease and increase.
Not the angle. The
Oh,
segment.
the segment.
Mhm.
Yeah, this like would also like the distance between this one and this one.
Mhm.
It would like depend on how much or you're increasing and decreasing.
Okay, so is it increasing or decreasing? So move this point right here. So as that angle gets bigger, the distance from B to D, what happens?
It decreases.
It decreases.
Mhm.
So if you were to tell someone, what would you say?
I'd say the distance is decreasing as this is increasing.
What is this?
Angle B.
Okay. So what if we were to shift, and we can't because that's not the way I did it. What if I were to shift this one over? If I were to, I don't think I can shift it.
This way?
Oh yeah, it doesn't allow you. But if you were to shift it,
Mm-hmm.
what do you think would happen to this angle in relation to this segment?
If I were to shift it this way,
Mm-hmm.
it would, like, the distance would also become, like, shorter, and
Mhm.
the angle would increase.
Mm-hmm.
Yeah, that makes sense. If it were to go, like, let's say here,
Mm-hmm.
then it would kind of, like, be this is this short, and it kind of, like, equal out, I guess.
Okay. So what do you think a difference between, and you said this is no longer a square?
Mm-hmm.
So what do you think a difference between a square and this shape? What did you call this shape?
Rhombus?
So what do you think a difference between a square and a rhombus is?
Well, with a square, all the sides are equal and all the angles are equal, while this one has parallel angles, so like this one would equal this one and this one would equal that one.
Okay. What else? Any other differences?
The distance with J and K are different as well.
Mm-hmm.
So like whichever one is across the other one, so like if it were B and D, this would also like, you know, be this length and then this one would be longer depending.
Okay. So if I were to draw this rhombus, so you said it's a rhombus, so I'm going to draw this rhombus here, or sketch it. Hmm? And let's say I told you this was 100 degrees. What would this be?
That'd be 80.
Okay, because of the relationship you mentioned?
Mm-hmm.
All right. And then I asked you, let's say this is A, B, C, D.
Mm-hmm.
Which one is longer or shorter, A to C or B to D, from the relationship you said? Which one's longer or shorter, A to B, A to C, or B to D?
It'd be B to D.
Why do you say so?
Like I said earlier, because when this is increased, the distance between is decreased, and then when this is decreased, the distance between is an increase.
Okay, that makes sense. All right, so good. So let's look at, so one of the differences, now we're going to write out the differences. So we have square and we have rhombus, right? And tell me, write out what you have for squares. What you told me the relationships were for squares.
So all the sides are equal.
Mm-hmm. Okay.
All the angles are the same.
Mm-hmm.
The distance between each angle is the same.
Okay. Between which angles? Are you talking about these two or the ones across from
Like
each other?
the ones across.
Okay.
So the distance.
Mhm.
Like angles across from each other.
Okay.
What else?
Okay. All right, so those are the relationships we talked
Yeah.
about. So now, as we changed it and moved this, what happened to the rhombus? Did the sides change?
Mm-hmm.
Were the sides still equal or weren't they? You can change it.
Um,
You can move it if you want to move that. Right?
So like the opposite sides were equal.
Okay, but not all of them were equal?
Yeah, like the opposite sides are equal to each other, and then the other opposite side is equal to each other.
Okay, so look at your numbers and shift it and see what's happening. Look at your numbers. Where the sides changing?
At the angle.
Look at this, F, G, H, and I are the sides. As you shift it, are the sides changing?
No,
So is it different for a rhombus?
the sides stay the same.
Okay.
The angles.
Okay.
But
Now-
the angles,
Okay. Which angles?
the opposite.
Mm-hmm.
Are equal to each other.
Okay. Okay, what else?
The distance between the opposite angles
Mhm.
either increase or decrease.
Okay. And how did that distance increase or decrease?
If the angles were decreased,
Mm-hmm. So let's look at one more thing. What do you think is happening here to these angles right here?
I think do they stay the same?
Do they?
Oh, no, they don't.
Do you think they change? So let's put it back to a square. Let's take it back to the square. Oh, there we go. Back to the square. Okay. So now, what do you think is happening here?
I think they stay the same.
You think they stay the same as I push it? You think anything's gonna happen to it?
Oh, no.
Let's see.
Doesn't seem like it.
No, they don't. Why?
Because they all, like, all the angles meet up to one point, and that one point should stay, like, same, even if you shift it.
Okay. So now, you were saying that, so what makes a square a square? Is it enough for me to just say the sides are all the same length?
No,
Why not?
because they can be the same length, but each of the corners could be a different, like, degree.
Okay. So, is it enough for me to say, so what do I need to say then?
So you could say a square has four equal sides, and each angle equals 90 degrees.
Okay. So what if someone says a square has four equal sides? And what else do you know about a square? You said something about this distance,
Oh,
right?
the distance between each angle is the same.
So what if they just said a square has four equal sides and the distance between each of the opposite angles are equal? Would that make it have to be a square?
No.
So let's say I do change the distance. Is it a
Oh,
square?
yeah. It's like it would have to equal the same.
It
So,
would-
like, yeah, what you said before.
What did I say?
You said the distance had to be the same on each opposite angle. So
What would be another definition of a square then? So you already said the first definition. What was your first definition again?
it was the sides had to be the same and the angles had to be the same.
Good. But what's another definition possible?
A square a square is a shape with four equal sides that have the same angle and the same distance.
Distance where?
From each opposite angle.
Okay. So can you make this definition any smaller? So now let's see what parts of this definition we can close off. So you said a square, right? Four equal sides, four equal angles, right?
Mm-hmm.
And then opposite angles, the distance, right?
Mm-hmm. Are equal to.
Distance of opposite angles equal.
Mm-hmm.
If someone just said this, would it have to be a square?
Yes. Well, yeah.
Okay, so if it has four equal angles and the distance of the opposite angles were equal, it would have to be a square? Let's see. Don't look. Okay, so this is a square.
Mm-hmm.
All right. And we're saying that as long as the angles, do you agree that this distance, D to E and here to here are the same?
Mm-hmm.
Let's see if which one can I move? Can I move this one? Oh. Can't move anything?